Hey guys, it's Mrs. Roberts, and today we're talking about Turgor pressure, okay? So Turgor pressure, we discussed Turgor pressure when we're looking at plants, and we're talking about how much water is stored in the vacuole of a plant. So let's start by defining Turgor pressure. And you should be writing these notes in your notebook on the page that your teacher has assigned. Turgor pressure, by definition, is the force of water within a plant cell. And where is water stored in a plant cell? That's right, it is stored in the vacuole. So the vacuole is like the main guy that we were talking about today. So let's draw a little plant cell here. Remember, our plant cells are typically square looking, and the plant cell has a really large vacuole in it. So there's my plant cell, and I'm going to draw a nucleus for fun. And inside my plant cell, or inside the vacuole, I should say, is water. So we're going to use blue to denote water. Okay? When we talk about Turgor pressure, we either say that a plant has high Turgor pressure or has low Turgor pressure. In this particular plant cell, the Turgor pressure is high. It is full of water, so it has high Turgor pressure. So our plant would look like this. Let's draw a little plant. Make it a little, put a pot here, and the stem, and the flower. Okay, so this plant has high Turgor pressure because it is standing upright. The vacuole is full of water. Another term we would use to describe this plant is turgid. So when I'm looking at this plant, I would say the vacuole is full. This plant has high Turgor pressure. This plant is turgid. All of those phrases would describe this plant. We'll come down here and draw another plant cell. It's going to look a little different this time. Here's my plant cell. And if you notice, the vacuole of this plant cell does not look like the vacuole of the plant cell up top. The cell wall of this plant cell does not look like this one. The one on the top of the page looks firm and upright. And this one looks like it's kind of caving in. That's because there's not enough water in our vacuole. So this plant cell would have low Turgor pressure. And when a plant has low Turgor pressure, it's going to look a little different than our plant up top. It's going to look something like this. Okay? So when we describe the vacuole, we would say this vacuole has a low water level and this particular flower or plant would be described as flaccid. Okay? So this plant cell has low water level in the vacuole, so it has low turgor pressure. It is a flaccid cell. It is a flaccid plant. Going back up here. I have water in the vacuole. The force of this vacuole is pushing onto the cell wall. So that means that this force is keeping the cell wall upright. Down here, this vacuole does not have a lot of water. So the force of this is less than the force of the cell wall. That's why this cell wall is caving in. This plant, this cell, has high turgor pressure. It is a turgid cell. This is a turgid plant. This plant down here has low turgor pressure. It has a flaccid cell, so it is wilting. This plant over here is wilting. And if I want my wilted plant to look like my upright plant, all I need to do is add water. Here are your turgor pressure notes. Have a great day.
Bet you thought you were done, but not quite. We have one more thing to add. So, recapping back, the force of the water within a plant cell, that's what turgor pressure is. But when we focus on what force is occurring, sometimes the force is coming from the vacuole, and sometimes the force is coming from the cell wall. And that just depends if the plant cell is turgid or flaccid. So I'm going to do a little demonstration, and I have a file folder. I have two of them that I taped together. This is going to represent my cell wall. And then I'm going to have a balloon, and that's going to represent my vacuole. So first, I'm going to demonstrate the full vacuole. So the air that I'm putting into the balloon is going to represent the water that you would put inside the plant. Okay, so we have a really full vacuole, and that vacuole is going to be inside of the plant cell. So right now, I have the vacuole that is pushing against my cell wall. So where's the force occurring? Is the cell wall pushing against the vacuole, or is the vacuole pushing against the cell wall? In this scenario, as my vacuole gets bigger, it's pushing against the cell wall. So on our notes, we're going to add, for high turgor pressure, you are going to add that force of vacuole is greater than the cell wall. The force of vacuole is greater than the cell wall because my vacuole was pushing against the cell wall. Well then, what happens if you don't water your plant? Slowly, that water is going to come out, so I'm going to let a little bit of air out of my balloon. And what do you start noticing that's happening to the cell wall? What is pushing on what? Well, as you can see, if I keep releasing that air, I have a lot of space now. And that's going to relate to my low turgor pressure. So now nothing is holding my cell wall straight and upright. Now it's pushing against the vacuole. And the more water that you release, the more that cell wall is going to push down. So for low turgor pressure, low turgor pressure, we would say force of cell wall is greater than the vacuole. So turgor pressure is always going to deal with the force. It just depends on what force is acting on which side, whether that is the vacuole or the cell wall. So make sure you add those two things to your notes, and then you are done with your turgor pressure notes.